Okay, great. So good morning, everyone. Thanks for joining us for today's NL seminar. It's my pleasure to introduce Kalpesh today. Kalpesh is a third-year PhD student at UMass Amherst, advised by Professor Mohit Iyer. He is primarily interested in natural language generation and the security of NLP systems. Before coming to UMass, he completed a bachelor's degree at IIT Bombay, advised by Professor P.T. Jayati. He has also spent time turning at Google, TITI Chicago, and Mozilla. His research is supported by Google PhD Fellowship, which was awarded in 2021. And I also wanted to thank Kalpesh for accepting our invitation despite our time zone. I know it's late there. Thank you for setting aside the time at this time to be with us today. And please, everyone, join me in welcoming Kalpesh and enjoying his talk. Thank you so much.
Yeah, thanks so much, Mosne, and thanks so much for inviting me. It's my pleasure to be here. Excited to present my research to you all. So yeah, as Mosne said, my name is Kalpesh. I'm at UMass Amherst, and today I'm excited to talk to you about text generation and its evaluation. So yeah. So I'll start by talking about large language models and talk about the revolution in text generation, which probably happened quite recently in Feb 2019, when a famous unicorn was discovered by GPT-2. So this was the exact generation. And as you can see, given just a prompt, the model generated this long paragraph of coherent text. And this was quite unlike any system seen before this, because text generation was pretty much in its infancy, and beside machine translation, we were not really getting very good coherent generations. And if this was not enough, in March 2020, not many people know about this, but in March 2020, the routing transformer model was released, and this had 8,000 length samples, fairly coherent. So this is one of the samples that really impressed me. It's a pretty long thing to read now, but I've just highlighted two different points to show its strength. You can see chapter 7 here and chapter 8, and despite the difference of about 4,000 tokens in middle, the model has figured out that it has to move to chapter 8 after chapter 7. And if you read this text, it's fairly coherent. It's got its mistakes, but yeah, it's really impressive to see that AI can do this. And shortly after that, in May 2020, we saw zero-shot generative applications, fully powered by GPT-3, the 173 billion parameter model. And whether it was React app generation or zero-shot NLP or poetry generation, text generation has really advanced in the last few years. And it has significantly improved downstream energy systems such as summarization, data-to-text generation, or even translation. But while the technology has improved a lot, I feel like the evaluation remains a struggle. You see, most papers continue to use n-gram overlap metrics like Blue and Rouge. And the problem with text generation is that there's a very large space of possible outputs, unlike tasks like classification. And due to the subtle aspects of the output are often ignored. So for instance, if you want to evaluate story generation, there are many subtle aspects that you'll care about, such as whether it's grammatically correct, whether it has appropriate syntactic complexity, does it follow logical ordering of events, or how surprising, interesting, or diverse is it? And just measuring Rouge overlap with reference summaries is not really going to get you this. In this talk, I will give concrete examples of why Blue and Rouge are bad metrics to use. So in this talk, we will focus on two downstream NLG tasks, namely unsupervised style transfer and long-form open domain question answering. And we will follow we'll follow the introduction and build systems that leverage transfer learning. Specifically, in unsupervised style transfer, we will use diverse paraphrasing and GPT-2 pre-training. And for the long-form open domain question answering, we will use recent advances in retrieval, augmented language modeling, or REL, along with contrastive learning and long-form pre-training. And we will follow the traditional NLP pitch and say that we get new state-of-the-art results. But I think it's more appropriate to write this as in this format with quotation marks, because we will soon discover that standard metrics are quite broken and they can be gamed really easily. So state-of-the-art claims are quite dubious. So without further delay, let's get started and talk about the first work on unsupervised style transfer. This is work done with John Whiting at Google and Mohit Iyer at UMass. And this appeared at EMNLP in 2020. So I'll start by defining unsupervised style transfer. Yeah, let's break it down and start with style. So we can define style as the patterns of lexical and syntactic choice, which are different from the content of the sentence. Yeah. So there have been several prior works who have tried to define style precisely. One really nice work in this space is Bhagat and Hovey 2013, who defined 25 different ways to change a sentence while approximately preserving its meaning. And they call these transformations quasi-paraphrases. We know that this definition is not universally accepted. And there have been several prior works who argue that you cannot separate style from the social meaning of sentences, and style and semantics are inseparable. But we'll continue with this definition because if you approximately allow preservation of semantics, you can unlock several real-world applications that we'll discuss a bit later. So moving on to style transfer. In this task, given an input sentence and a target style, the goal is to rewrite the input sentence using the target style while preserving semantics. And you want to ensure that the content of the input and output are similar. So to give you an example, here's a sentence from Shakespeare. Oh, will thou leave me so unsatisfied? And we want to rewrite this into a Twitter style. So this is what an output will look like. Oh, you will leave me I cannot read this. Yeah. Oh, you will leave me so sad with a sad face and a number of question marks and the small u. So as you can see, the content has been preserved, but a number of other aspects of the text has changed. So moving on to the unsupervised style transfer part. We'll follow the setting in many prior works where we don't have access to any paired data between the two styles. So we do have access to a number of sentences in each of the two styles, but they're not paired. So for instance, you can see the mention of Trump here, but of course we won't have any mention of Trump in Shakespeare. And as you can see that there's no content overlap between the two corpora. So there's been a lot of recent work in style transfer, and most of them we find face a similar kind of issue. We see that models significantly modify the content of sentences. So for instance, here are some outputs from a popular model, Lampel et al. 2019. And as you can see in this first example here, Christmas tree has been modified to computer and Star Wars has been modified to the voice. And you'll see this trend in nearly all the pairs here, that content is significantly modified. This happens because attributes differ both in style as well as content, and prior works have studied this in detail. So just like I mentioned before, you can see Shakespeare and tweets here, and you won't have any mention of Trump in Shakespeare. And because there's difference in content, models learn to So because there's difference in content, these unsupervised style transfer models learn to map content words between the two corpora as well. So why is this a problem? So the problem is that many real-world applications of style transfer require semantic preservation. So take any example such as text simplification, data augmentation, auto obfuscation, empty evaluation, or even control generation. Semantics are a really important part here. And without semantic preservation, the model is not going to be very useful. And while it may be cool to see outputs being transferred in like this previous slide, it's really not that useful because you want semantic preservation in all these real world applications. So without further detail, let's get into the actual content. So in this work, we will first present a simple new state-of-the-art unsupervised algorithm, which models style transfer as a controlled paraphrase generation task. We will then focus on evaluation. We will survey 23 papers and suggest improvements to evaluation. And finally, we'll briefly discuss a corpus of 15 million sentences from 11 diverse styles, which we built in order to move style transfer research to a more real-world setting. So before I get started, I just wanted to ask if anyone has questions. Okay, so I'll just go ahead. So we want to transfer style of sentences, but at the same time, we want to preserve semantics. So here are some Shakespeare and Twitter sentences. And what we ideally need is paraphrases of these sentences without the style in them, so that we can train models to map sentences to insert the style. But the problem is we don't have access to this paired data. So what we can do is we can create pseudo-parallel data using a diverse paraphrase generation model. So for instance, here are the Shakespeare and Twitter sentences again. We pass them through a diverse paraphrasing model in order to generate diverse paraphrases where the style has been significantly stripped out. And then during training, we learn these inverse paraphrase models to insert the style back into the sentences. So as you can see here, we are going from Shakespeare to diverse paraphrases back to Shakespeare. At inference time, we can just swap the inverse paraphraser in order to style transfer. So this is the train time procedure from Shakespeare to diverse paraphrase to inverse to Shakespeare again. We just swap the second model in order to do inverse paraphrasing. Shakespeare to paraphrase to Twitter. And note that all these outputs are actual generations from our system. In order to build this diverse paraphrase generation model, we trained it on back-translated data from ParanMT 50 million. But simply training on that was not sufficient because the outputs were often quite generic. So what we did is we aggressively filtered ParanMT 50 million in order to maximize similarity and most importantly, diversity of the sentences. By diversity, I mean lexical and syntactic diversity. Diverse paraphrasing has this normalizing effect where it strips stylistic features from text. So to give you a precise example, here are 11 different styles. On the left side, I have done a TCP plot of these 11 different styles using feature vectors from a Roberta classifier. If after I do diverse paraphrasing, you can see the clusters on the right side. On the left side, the clusters are very well formed and they're easy to classify. Whereas on the right side, the clusters get distorted because style has been stripped out of the sentences and it's much harder to classify them. Precisely the classification performance on these clusters is roughly 88%, whereas on this it's about 40%. So our approach is called STRAP, or style transfer via paraphrasing. And note that we train, like every component of this model is built by fine-tuning GPT-2 large, which significantly helps improve fluency as well as generalization. So with that, I'll move on to evaluation. I'll just quickly stop to ask if there are any clarification questions at this stage.
Yeah, so it sounds like what you're saying is that when you so ParanMT, I had to look this up. This is a corpus of paraphrase sentences, right?
Yeah, so it's a large back translated corpus. So it started from English sentences, moved to Czech sentences, and then back to English. So it's like rough paraphrases,
Okay.
which is quite, yeah.
So you seem to imply that what you produced was sentences without style, right?
Yeah.
I sort of have to take objection to that. So you showed that they did not have the styles that you started with, I suppose. So these diverse paraphrases, these are plots of the transformed inputs, right?
Yeah.
Okay, but that's not to say that they don't have styles of their own, right? So, I mean, is it not there's no such thing as not having style, right? Like there's always a style. It's just,
right.
So I would say that given that if the input is from back translated English to Czech, then you're going to have some kind of translation ease as your style, right?
Yeah, definitely. So the important thing is diverse paraphrasing here. So by diverse paraphrasing, I think stripping is a wrong word, changing is a better word. We are changing the style of the input sentence because it's a diverse paraphrase. So the syntax and the lexical choice is being changed significantly.
But why do you think what gives you reason to believe that it's diverse as opposed to simply all translation ease?
So it's diverse because of the filtering that we have done. So we did not just take back translated sentences. We only took those sentences which had a significant modification of lexical and syntactic constructions. And we only took those sentences which had high similarity with the input. So we had a ParanMT corpus of 50 million sentences, and this was filtered down to 75,000 sentences.
Right, but that doesn't mean that you have diverse style. In diversity, do you mean diverse styles, right?
No, so by diverse paraphrasing, I mean the input and output mean the same, but they use very different words and syntax. That's what I mean by diverse. Yeah.
All right. So the data is all back translated Czech, right? So if there is going to be some kind of style transfer that happens from that, you would assume that it's going to be translation ease that gets in there. And I wonder if you've analyzed to see if there is a kind of style bias that gets in from using that specific kind of data.
Yeah, it's possible, but the important thing is here that it's a two-step process. So you're moving from Shakespeare to the translational ease input, and then you're doing an inverse paraphrasing back to the original. So the hope is that the bias will be corrected in the second stage. I vaguely remember we did some experiments on this. It wasn't specific to translationals, but we were trying to see if it's just sufficient to do one step of this two-step procedure, and that wasn't giving as good performance as this two-step process.
Okay.
Yeah. Okay, so moving on to evaluation. So so I'll just introduce evaluation and style transfer. So style transfer is typically evaluated on three different aspects. The first is accuracy. So that is whether the output sentence is actually respecting the target style or not. So here's an example of an input sentence, wherefore art thou Romeo, and you want to translate it to tweets. So the goal output would be, why are you Romeo? But an error could be you just copy the input sentence and you're still sticking to the Shakespeare style. The second is similarity. So you want the input and output to have the same semantics. And in this case, like we have the correct style, which is Twitter, but we have modified Romeo to Juliet. So it's a sentence with a different meaning. And finally, fluency. We want to make sure that the output is grammatically correct. So in this case, this output is not grammatically correct. And a fourth metric could be like combining these three independent metrics into a single score. So this is quite important because—
Just a quick question, clarification question. You're making a distinction between grammatically correct and stylistically correct?
Yeah. So most style transfer literature makes this distinction where you want to make sure that your sentence is like it has the correct style, but it also you also want to make sure it's fluent. So yeah, and you also want to like combine these three metrics into a single score, because this is important in order to like compare systems and do hill climbing. You often have a case where your new system is better on one aspect but worse on the other aspect, and you don't really know whether it's doing a good job. So we did a survey of evaluation practices in 23 style transfer papers, and what we found is that a lot of standard evaluation practices are flawed. We proposed some fixes to current practices. One thing in particular we noted is that metrics are rarely aggregated, and it was not really clear whether systems are really better than baselines, because they would help in one metric but be worse on some other metrics. A few papers tried to correct this by using aggregation on automatic metrics. And what they did was they used this flawed aggregation where they use the geometric mean of these three different metrics of accuracy, fluency, and similarity. But this is quite flawed, and we will see why. So let's say we are translating from Shakespeare to tweets. We can do some simple heuristics where instead of actually doing style transfer, we just do things like copy the input exactly. So this will help you get full on similarity and fluency, but zero on accuracy. And the second thing could be you just output a random sentence from the target style. So this will get you full score on accuracy and fluency, but zero score on similarity. And then when you average these metrics, you get a reasonable accuracy, similarity, and fluency. And if you take a geometric average of this, it gives you a pretty good score of 0.6. So this is quite bad. And if you apply this on a large scale, what you'll see is that this method can like outperform some popular state-of-the-art baselines from 2020. So they get 58.7 and 58.5 on after geometric average. But if you just do input copying or random retrieval, you can get up to 58.9 score.
Sorry, just a quick question. What did you mean by accuracy, and why was a random sentence able to get a perfect accuracy?
Yeah, so a random sentence will get a perfect accuracy because you have access to train time sentences in the target style. So you can just pick a random sentence from the target style, and that will get you full accuracy because—
So accuracy means accuracy of the target style?
Yeah, accuracy of the target style.
How is that calculated?
It's typically calculated using a classifier, which like classifies whether the sentence is in the correct target style or not.
Okay.
Yeah. So this is quite problematic, and yeah, and
one more question. So is it the same way the other two metrics are computed? Are you also training classifiers to compute all the metrics or just for that?
Yeah, so this is quite debatable in literature. So for fluency, there's a big conflict between perplexity and classifiers. At least in our work, we have used a classifier throughout. For similarity, there's a conflict between BLEU and like more deep, like deep models like SIM or BLERT. In our work, we have used SIM, which is like a paraphrase similarity model. And because these metrics have their shortcomings, it's important to do human evaluation as well, where you ask humans whether the sentences are paraphrases or not, and whether they are fluent sentences in the target style or not.
Okay, thank you.
Yeah, and yeah, you have training corpora to train models for all these tasks. So. Okay, so this is a problem, and luckily the fix is not that difficult. So what you can do is you can instead of doing a geometric average of the average scores, you can just aggregate scores at a sentence level. So out here, if you so you can just multiply the scores here, and that will give you an aggregate score of 0 and 0 because none of them are actually style transferred outputs. In other words, you want to simultaneously maximize all three metrics. And as you can see, these two sentences are not simultaneously maximizing the three metrics, so they get a score of 0. And then you can do an averaging to get a final score of 0. So we will use this sentence level aggregation for all our comparisons. And moving on to the main results, we see that our model outperforms prior work on automatic evaluations. So as you can see that we do pretty well on similarity and fluency. And if you do a sentence level aggregation, we are much better than baselines. And there's a consistent trend, even if you do a human evaluation of these models. We can see a pretty high sentence aggregation scores compared to baselines. And because our main pitch was paraphrasing and diverse paraphrasing, you can see a much larger increase in similarity compared to the other metrics. Finally, I'll briefly touch upon this new corpus that we built in order to move towards more real-world style transfer settings. So this is a new corpus of 15 million sentences in 11 diverse styles, which we hope will be useful to the community. So yeah, so what we felt was that previous benchmarks are sort of toyish settings. So firstly, many of them have been carefully curated to remove noisy text, which is not necessarily a bad thing, and it's very good for progress. But the issue is that real-world text can be quite noisy. And many of the previous corpora had only 2 styles. And while they were unpaired, they often had the same content distribution because they were originally paired corpora and then they were shuffled in order to make them unpaired. So we wanted to move from this setting, and so we extracted a number of different styles from the internet, and we extracted a total of 15 million sentences and did very minimal pre-processing to them. And there are 11 diverse styles in this corpus. These styles include authors like Shakespeare and James Joyce, different kinds of tweets, poetry, speech transcripts, lyrics, historical fiction, and biblical text. And all these different styles have their own unique properties and features. Oh yeah. So yeah, so here are some examples from the corpora, and as you can see, like they all have their unique styles, and they have completely different content distribution. So it makes it really hard for the model to like learn mappings between the 2 sentences, between any 2 pairs of corpora, and they have a pretty diverse vocabulary too. So yeah, so we trained a model on this benchmark, and it does better in prior work, but I think there's still a long way to go. So here are some outputs from our system, and yeah, at least these outputs look good, but at the same time, there are like the model is making a number of errors too. So yeah, so for instance, it makes the typical errors that text engine systems currently face. So for instance, it sometimes misunderstands rare words. In this case, importune, it interprets it as import. It sometimes drops semantic content, and we realize this is often happening in the first step of paraphrasing. It's probably related to the fact that the back-translated text is quite noisy. And finally, yeah, we also have like the problem of hallucination, where sometimes semantics are just added arbitrarily. So yeah, with that, I'll just pause again for quick questions, and then before I move to the next work.
The works that you compared to with your multiplying aggregation across sentences, that was, you took their raw scores and then did aggregation to show what the difference was. Is that the idea?
So I took their outputs directly, and then I compared them with, I think, both their eval and our eval, and then I did aggregation on both of them.
When
So
you,
yeah.
when you were, did you use the aggregation as part of your objective?
Which objective? You mean the training objective?
Correct.
No. So the aggregation is not used in any training objective. It's only for evaluation.
Okay, great.
Yeah. So yeah, the objective is just next word prediction loss to, in order to do the paraphrasing and then the inverse paraphrasing. That's all. Yeah, and we also don't use any classifier during training. I think the middle baseline uses a classifier, and this baseline doesn't use a classifier as well.
Question. So can you say a little more about how do you create a diverse paraphrase dataset? Let's say I want to do it in Spanish. What do I need to create a diverse paraphrasing?
Right. That's a great question. So what we did was we first took a lot of back translated data, which is about 50, which had like 50 million sentences. And these are like pairs of approximate paraphrases with all the caveats that they have translationese and they are noisy. So first, what we do is we filter it to make sure that the input and the pairs have high semantic overlap, which can be done using automatic models like SIM or BLERT. And once you get like the good translation pairs, the next thing we do is we measure unigram diversity. So that is measured by the number of tokens which are overlapping between the two sentences, and we try to like make sure that the overlap is minimum. And finally, the third thing is, which I think is new in this work, is we try to maximize syntactic diversity using this trick where we want to make sure that the input and like the pairs have a maximum reordering of words. So what we do is we find all the common words between the two sentences, and then we sort of see, we sort of measure the bubble sort distance between the two sentences. And we try to make sure that the bubble sort distance is maximized. And then we keep thresholds for each of these criteria and then just choose the sentences that satisfy all three criteria.
Got it. Thanks.
Yeah. And yeah, I'll just mention that I'm familiar with some like other works too, which are like trying to like filter out paraphrases in order to extract things like reduce toxicity or do other things like like get out specific aspects that they care about. So this seemed like an interesting way of getting interesting behavior from a large scale translation data set. Okay, so moving on to the next part. So this is about long form open domain question answering. And this work was done with Orko Roy and Mohit Iyer. This appeared at NACL earlier this year. So again, I'll start by defining long form question answering. And in long form question answering, given an input, which is an information seeking question, often a how or a why question, the goal is to generate a paragraph long abstractive answer. So for instance, in this question, how do jellyfish function without brains and nervous systems? A model must generate this 327 word long paragraph, which sort of answers the question and like gives users an information rich knowledge grounded answer. And yeah, this example is from the ELI5 dataset, which was released in ACL in 2019. This is the only large-scale long-form question answering dataset as far as I'm aware. So this has about 512, I think it has about 256,000 such pairs, all extracted from Reddit ELI5, where people ask such questions and then other people answer those questions using these paragraph long answers. So it's sort of similar to Stack Overflow and Yahoo Answers. But yeah, I think it's just like a much bigger data set. So we study long-form QA in open domain settings. So here's a typical squad-like setting where you're given a paragraph and you have questions about the paragraph, and your answer is guaranteed to be within the paragraph. But open domain question answering doesn't operate that way. So in open domain question answering, you don't have access to a paragraph. You just have the question as an input. And you need to search from Wikipedia in order to find relevant information, and then use that information in order to ground your answers. Yeah, so this task is pretty important because it's seen a lot of popularity in the last couple of years. Open domain QA is now used in search engines, dialogue agents, as well as it can be used for information extraction. And there's been a lot of prior work, but most of it has focused on factoid extractive answers. So in these cases, the answers are typically just an entity or a date located somewhere on Wikipedia. And the answer is exactly present in a single source document. So you don't have to like look at multiple documents and synthesize information together. Yeah, there is some work on open domain hotpot, open domain multi-hop question answering, but still the final answer is only in a single document. So yeah, there's been much lesser work on long-form QA, and we hope that research in long-form QA will help bridge this gap, because a number of questions that a user might have cannot really be answered with just a single word and require a more extensive paragraph-long answer. So with that, I'll just present an outline of this project. So we present a new long-form QA system, which gets state-of-the-art results on ELI 5. And then we do an extensive analysis of the system, and we find several concerning trends related to evaluation and like the data set itself. We'll see that retrievals don't really impact model generations, and the evaluation metrics don't really pick up on this. The data set has a lot of train validation overlap in terms of questions and content, which sort of like avoids the need of retrieval at all. And finally, we'll try to game RuGel similar to how we did it for the style transfer metrics. And we'll see several concerning trends and why RuGel is a very bad metric for this task. So yeah, I'll get started with the system. Just wanted to pause once again for any clarification questions. Okay, so we follow a typical two-stage pipeline approach to open domain question answering, which is quite standard in current literature, where you first retrieve and then generate. So let's say you have a question, why are all boats white? So you start with this and you search Wikipedia. We pass it through a retriever, which we call CREL, and it's basically a dense retriever which is based on REL. I'll explain it in a bit more detail later on. And we use this to retrieve a number of Wikipedia articles. In this case, on boats, ships, and paint. Then given these articles and the question, we pass them through a generator model, which is, in this case, we use a routing transformer model. And I'll explain why we use this model compared to something else like GPT-2. And yeah, using this, we can we train this model in order to convert these documents and this question pair in order to a long paragraph-long answer. And yeah, one important thing is in our system, we don't backpropagate from the language model to the retriever. We did try this in the initial experiments, but it didn't really help. So we just ended up with a pipeline approach. So our generator is a sparse attention model, and it's pre-trained on long-form language modeling. It is a routing transformer model, which is appearing in Tackle this year. And this model is the state-of-the-art model on the Project Gutenberg 19 long-form language modeling benchmark. And the key idea here is sparse attention. So because you have very long sequences in Project Gutenberg 19, and typical models, like you cannot do full attention because of memory constraints. Sparse attention uses clustering tricks in order to like attend over only selected tokens. And this really helps compared to like other local attention models, and it helps get a state of the art on Project Gutenberg 19. And another reason to use this pre-training is because it's seen such long form text during its pre-training. It's sort of inclined towards like it's sort of inclined toward generating long pieces of text, which is what our task requires as well. So moving on to the retriever. So retriever training is a little tricky here because we don't have access to gold retrievals. Like I said, this is a fully open domain setting, so you don't have access to Wikipedia articles which sort of ground the questions. So we need to sort of estimate this automatically. Yeah. So we use this distance supervision approach using contrastive learning. So the key idea here is that Wikipedia articles, at least at a paragraph level, and ELI5 answers sort of look similar in the sense that they're both paragraph long. And what we can do during training is that we can treat ELI5 answers as Wikipedia retrievals themselves. And then we can train this dense retriever model where we basically map questions in order to, we map questions to vectors, and we map answers to vectors. And we train the vectors of the question and the answer to be close to each other, and the question and answers of and some negative sample answers to be away from each other. And by doing this, what happens is that we learn a vector space where questions and paragraphs are being mapped to a same embedding space. And then during inference, we can replace these answer paragraphs with Wikipedia retrievals themselves. And yeah, this idea is from Journite 2020. This is which appeared in a blog post last year. Yeah, so this works because both answers and Wikipedia retrievals are paragraph length. And so one important thing is that we scale up from prior work. We use very large mini batches of size 12,000. And we also initialize a retriever with this popular retrieval model called REL. These two design decisions really help, because in contrastive learning, you want to have very good negative samples, or you want to have a lot of negative samples. And doing this helps learn better representations and a stronger retrieval model. So yeah, just wanted to pause before I move to results. If there are any questions. Okay, sounds good. So moving on to results. So in terms of retrieval, what we see is that our model, despite being our retriever, despite being distantly supervised, it's similar to the retrieval performance from other systems like RAG and BART plus DPR, which will be our main baselines. They are similar sized models in terms of parameters, about 600 million parameters each. But in terms of generation performance, at least in terms of RUGEL, the performance of our model is significantly higher, getting 23.2 RUGEL compared to 14.1 and 17.4 for these two models. And if you aggregate these metrics together, which is basically like combining these metrics at a sentence level, we achieve a new state of the art on this task, getting an overall score of 2.4 compared to 1.9 and 1.7 in the baselines.
Is that a per sentence aggregation, or is that did you just multiply those two numbers together?
So I think this is done at a sentence level. It's sort of similar to the evaluation done, like the sentence aggregation done in the style transfer work. So you sort of multiply you sort of multiply your retrieval score with your generation score, and then you just take that as your and then you average that. So if you get all your retrievals correct, this would have been 23.2. You can see that it's roughly a multiplication of retrieval into generation score. Each of these are percent. You can think of each of them as percentages. Yeah. Right. And yeah, just want to clarify that this is not something we came up with. This is just what the official evaluation leaderboard uses here. Okay, so yeah, if you look at the generations, they have their flaws, but like they're long, relevant, and fluent. They do have repetition, and if you read it carefully, like you might find this output a bit funny. And you see that trend in like most of the outputs, like they're long, relevant, somewhat fluent, but then they have some repetition, and they don't make sense if you read very carefully. But one very interesting thing is that if you like read the retrieval and then read the generations, you'll see that the retrieval are like the generation are not really copying things from the retrieval. Like it's just sort of babbling on its own and sort of producing facts on its own. And like these metrics are not really testing whether the generation are actually using the retrievals that they have been trained to use. So we decided to test that. And to test that, we designed this really simple experiment where we took a trained model and we just replaced the predicted retrievals with random Wikipedia paragraphs. So we tell the model to like condition on these random Wikipedia paragraphs and then try to answer the question. And what we see is that there's very small differences in generation quality between these two models conditioned on actual retrievals and completely random retrievals. So in terms of RUGEL, the difference is only 0.2. In terms of unigram overlap with the original retrievals, it's roughly similar. It's about 50% each. And because RUGEL can be problematic, we also did a human evaluation where we showed humans these two paragraphs in a random order. And we asked them to choose which paragraph they found more relevant and answering the question better. And we found a very small difference. In fact, with nucleus sampling parameter p equal to 0.9, which is one of our configurations, we found that the random retrieval model was slightly preferred over an actual retrieval model as well. And yeah, there are more experiments in the paper to support this hypothesis that the models are not really using the retrievals. It's just like sort of babbling on its own. But this is quite strange, because if you like read the outputs from the random generation model, like this, you can read the first line here. You can see it's mentioning things like Faraday cage around your electronics, which protects them from solar flares. And this is a pretty it's a fact that's almost correct, and it's quite strange that the model can like produce this fact, given that the retrievals were like completely random paragraphs, and even during pre-training it didn't really see Wikipedia. It was only pre-trained on Project Gutenberg 19. So what we find is that this is at least partially explained by the fact that the ELF5 dataset has a lot of question overlap between the train and validation splits. And in order to do this, we first try to find question paraphrases between the validation set and the train set. So we just reuse our retriever, where we had trained a question encoder mapping questions into a vector space. And in this vector space, we just find the top 7 nearest neighbors from the train set. And then we use those questions as question paraphrases. And then we analyze these question paraphrases with mturk and a question paraphrase classifier. And quite surprisingly, we find that, like, at least according to mturk evaluators, about 81% questions had at least one paraphrase among the top 7 retrievals. And they found that all the questions had at least one topically similar question in the top 7 retrievals. The top 7 question paraphrases. And we also like verified this with a question paraphrase classifier, which is trained on Quora question paraphrases. And here we find a similar trend with like 44% questions having at least one paraphrase in top 7. Note that this number is much smaller, and we think this is a lower bound because like we saw that this classifier is not that great and it's missing a lot of paraphrases. And it's also like it has a bias towards marking no paraphrase. I think because of the training set distribution. So just to verify this, we also like manually verified all these 81% examples, and indeed like all of them were paraphrases. So since we have question paraphrases in the train set, we can just use that as a question answering system itself. So instead of actually generating an answer, you can just take a question from the train set and copy over its answer as your system's answer. So here are the baselines again, and along with our model. So if you take the top 1 retrieval and among its reference answers, you just take the longest answer, you can get a root gel of 20.7, which is better than 2 of the generative baselines. And if you take like the very best answer among the top 7 retrievals, this gets 28.5 root gel, which is like the best root gel score that we got in all our experiments. So indeed, like the questions are very similar in the train and validation set. And this is probably happening because like the data set was not constructed very carefully, because like they did not really do things like hold out entire genres of text or hold out certain time periods, whereas it was just a random shuffling of questions. And like this might remind you of like the similar question suggestions that you get on websites like Quora or Stack Overflow. People like to ask the same question again and again, and that's why like there's so many cases of questions appearing again and again in Corpora. And I think there's been some work in EACL 2021 as well, where there's been a similar finding on the natural question dataset, where there's a lot of overlap between the training and validation sets in terms of question paraphrases. So yeah, moving on to the final part, we wanted to like just see what these root gel scores mean and whether they are meaningful at all, and whether they can be tricked similar to how we trick the style transfer systems. So we try to design baselines to upper and lower bound root gel. So for lower bound, we use the exact same ideas where we either took a random training set answer, or we just copied the question exactly. And I think we copied it 5 or 10 times in order to match the average answer length. So very surprisingly, this gets pretty high root gel scores, 16.2 and 20.0, which is again better than the previous 2 state-of-the-art baselines, both RAG and BART plus TPR. It does underperform our model, but this number is dubious. So what we do is we try to upper bound RuGel. And what we do is we take the gold answers themselves and try to compare them to other references. So like every answer in ELI5 has typically 7 to 10 references. So we just pick one at random, or we take the longest answer and measure the RuGel with the other 6 to 9 answers. And we find that the longest gold answer gets a RuGel of only 21.2. And similarly, the best gold answer gets a RuGel of only 26.2. And
sorry.
this is, yeah.
In that evaluation, you're comparing to n-1 possible answers though, right?
Yeah, I agree that yeah, that's
so.
True.
Whereas in your numbers, that's n answers, right?
Yeah, yes.
So it'd probably be fair if you scored yours using n-1 to get numbers that are comparable, right? So the whole scale shifts when you change the number of answers.
I completely agree with you. And there's one more issue here that the other issue is that when people write on ELI5, they look at one answer and then they try to like provide complementary information in the other answers. So this number is likely to be a little higher. But still, when I say best gold answer, what I mean here is I take every pair of answers and see which are the two most compatible answers in order to get this 26.2 RuGel score. But yeah, I completely agree with you that there's a slight scale shift n to n-1, and people like to write complementary answers here. Okay, so what do these numbers really mean? And like, is our system really better than the gold answer? So we do a final human experiment where we sort of check human preference between the gold answers and our model's answers. And we find that humans significantly prefer the gold answers over our model's answers, 77 to 23% in this same p equal to 0.9 setting. So yeah, so clearly the metrics are not really capturing what we want. And there is like better metrics need to be designed here. Finally, I'll just mention that we interviewed the human evaluators just to get a sense of what they were looking at and what they thought about evaluating these long form generated texts. And they said that the length of answers made the task quite challenging. So a lot of concentration and careful thought was needed. And like they were typically taking about 2 to 3 minutes per question answer pair, and then often feeling tired after doing like 3 to 4 pairs. And they said that it was quite hard to judge or compare the correctness of answers when only a part of the answer was good. They also said that they were sometimes unfamiliar with the topics of the questions. And while they had access to Wikipedia and search engines, they could not always verify whether the answers are technically correct. And they said that topic experts would be the best judges. So yeah, so with that, I come to an end to the 2 works. I wanted to end with one final slide on my opinions. Like, yeah, it's not really any research, but just opinions I have after reading recent literature in evaluation of text generation on what I think could be the next steps in improving text generation evaluation. Yeah, so before I move to that, just any other clarification questions at this stage?
Yeah, thanks, Kalpesh. Thank you for the great talk. And,
yeah, I just have one more slide actually.
Sorry.
Yeah. I just have one slide, but I just wanted to say what I think about evaluation text generation. It's mostly opinion driven, but yeah.
Sorry,
so yeah,
understood that.
Yeah, no worries. So yeah, so I was just broadly thinking about what could be the next steps in evaluation of text generation and what are the main trends that people are doing these days. And I think most of them are very good directions. So the first is like, we want to probably precisely define the properties that we care about. Probably ask end users to like label things about the certain properties that we care about and like try to get these fine-grained annotations. So this is very helpful because once we have these annotations, we can train these deep evaluator models where we sort of pass in the where we pass in our generation and then ask a model to like check whether the generation is satisfying some criteria. So I think the biggest example of this of this kind of work is in translation, where you had this recent paper on BLERT, which basically like trained BERT on like these fine-grained annotations and like got very good evaluation performance. There have been similar efforts in question answering and also more recently in factuality of summarization, where people are like trying to use question answering systems in order to like check whether summaries are factually correct or not. And here are like 3 works which do that. The second step could be like more robust human evaluation beyond mechanical Turk. And like one work I'm particularly excited about is this work on Storium, where expert annotators and humans are, and people who like actually care about the generated text are evaluating the text rather than people who are just, rather than M-Turkers who are like not really interested in a task and are doing it for other reasons. So in the Storium benchmark, the main idea is that you want to, it's a story generation evaluation platform. And the generated outputs are sent to a real-time server where people are like using these outputs in order to write their stories, in order to like help themselves write stories. And yeah, they're very passionate story writers. And based on like, and what the system does is based on how much the text is edited, it sort of evaluates how good your generated text was. And then users can also give feedback like they like this aspect of the system and they did not like this other aspect. The third thing that's happening these days, which I think is a great step, is more standardization of evaluation metrics, which is basically like the glues of text generation evaluation. So there have been 2 efforts in this space recently, which is the GEM benchmark and the Genie benchmark. And yeah, I think that the GEM benchmark is a shared task at ACL this year. The goal of this is to like collect a lot of people and like sort of standardize what we care about in text generation and like how we should go about evaluating systems going forward. And yeah, finally, I just want to point out to this really good survey on text generation evaluation, which sort of like, which really like helped me think about these broad themes and like basically write the slide. So yeah, and this is from Microsoft Research. So yeah, thank you so much for listening. With that, I come to an end. And yeah, happy to answer any questions you might have.
Thank you so much. Thank you for the interesting talk, Kalpesh. Specifically, it was really interesting that you looked into how the retrievals are not actually helping. It was a really good analysis, I believe. So with that, I think we can open the floor for the questions. I think Jay has raised his hand. So Jay, I think you can go ahead. And of course, sure, we can go ahead with other questions as well.
Yeah, so I think one of the things that I was struck by in your talk is sort of a lack of novelty, right? So not novelty of your work, the novelty of the generation. And what it sounds like is that if you have a sufficiently parameter heavy model, you can just effectively find nearest neighbor to something that's been said before. And so can you think of ways, or do you have some thoughts on this sort of idea of novelty? Often if there's a question that's already been asked, you can kind of repeat the answer. But for a story, if you see the same story, maybe you're not as excited, or maybe there are enough stories out in the world that it doesn't matter. So is novelty necessary? And if it's not, then has everything meaningful to say been said already?
Yeah, I think that's a great point, and I think I'm like, at least for tasks like story generation, I think novelty is a pretty important requirement. For long form question answering, it's harder to say, but it's sort of like I think one example of this could be like how often we try to find answers on Google search, but like how often we are not really satisfied with the results. So we really want one system to like sort of synthesize information for us and like provide answers to us, rather than us having to like go through a number of articles and like come up with answers itself. So I think like the simpler questions have already been answered on the internet, but as soon as you start moving to the tail distribution of questions, things get quite tricky, and I think novelty is pretty important there. And you also like keep having these world events where like new questions keep coming up, and you're not going to find existing resources which have the exact same thing answered for you. So you want like the systems to be able to like understand information, reason over them, and then sort of provide answers or insights to you rather than just copy something that's already provided online.
Yeah, that's an interesting insight. So do you have a way of understanding what the tail questions are in this domain or in domains in general versus sort of the head questions? Or questions that are not
Right.
extensively answered online already, right? That's sort of what I take to mean the tail question.
Right. So yeah, I think so. Yeah, I think the question paraphrase finding method could be one way to go about it. Like, so yeah, I'll just repeat what we did there. So so through the whole retrieval training process, what we eventually get is this deep network which maps questions to vectors, and these vectors sort of map questions which have similar answers to similar parts of the vector space. So what you can do if you have this vector space is that you can map a corpus of questions in order in order to this vector table. And then when you have like this, you want to check whether a question is whether you want to check whether a question is novel or not. You can like try to see whether it's close to any questions in this vector space. And if it's like distantly far away from a number of other questions, it means that it probably means that it's sufficiently novel. Like, at least looking at these question paraphrases, I thought that it was pretty good at discovering whether questions are similar or not. And this is not just with the retriever we trained, it was also what I saw with the retriever from Realm, and I think even the RAG retriever. Like, they were pretty good at finding whether questions are similar or not. I'm not sure if that answers the question, but yeah, that is just like a methodological perspective on how tail questions could be found.
Yeah, I mean, I think it sounds like a really interesting future work question to then say, okay, here are the low density space of the vector space, and let's see how the performance updates. So thanks so much for your answers.
Yeah.
Can I sneak one last question?
Yeah, go ahead, John.
So thanks. It was a really nice talk and really good analysis. To follow up on what Jay said, though, at the beginning when he was talking about creativity. So I think the tasks that you decided to evaluate on could be thought of as somewhat creativity low, much like machine translation is. Not to say that the creativity isn't involved in doing any of these tasks by a human, but there's no invention, right? Like, so there's kind of an objective truth component to each of them. And I wonder if the methods that you followed and the methodologies for analysis would hold up when you get to the way more open tasks that still have like pretty strong agreement as to correct or incorrect. So I'm thinking specifically of like dialogue and like creative generation, like story generation. So in general, do you think that the work that you've done is applicable, or do you think that a whole new direction needs to be done to handle these much more open generation tasks?
Right. So do you mean in terms of evaluation or in terms of methodology? And
both, whichever you'd like to answer.
Okay. So yeah, I think in terms of evaluation, story generation is much harder than each of these tasks. Just like you said, because like the content could be literally anything, and you want to reward content that's novel, and you want to reward content that's novel and that's not already there. So I think like evaluation is really hard in story generation, and you really want to like do like I think Storium is a good is a good step in this direction, because like you're actually doing what you want your story generator to do, that is like help like assist people who are writing stories. So if you can like get direct feedback from them, I think that's the best way to like guide models. Of course, like because people are reading them, like they may not be able to like precisely verbalize what aspects of the story they liked and like precisely mention like what they want improved in the story generator. But still, I think like evaluation in like for these much more unconstrained tasks like story generation, you probably want this human in the loop setup. Though I do feel that some aspects can be tackled in a more automatic way. So I think like perhaps models can be built to evaluate coherence, and I think a number of like at least some story generation works do have like these sophisticated models to check coherence. And I guess even this work on evaluating factuality and summarization is promising. it's promising in a lot of long form generation tasks, including story generation, where you can check consistency, and you can like ask questions about the story and like see if it's consistent with what the premise was. Regarding methods, I'm not like I have mixed opinions. Like it seems like the largest language model is going to like it seems like the largest language model is still not there, and we really don't know what is the upper bound of increasing language model sizes. So I think like I do think paraphrasing is a promising thing, and it can be incorporated in a number of natural language processing tasks. For story generation, I'm not quite sure, and I spoke a bit with like the Storium authors on whether like something related to paraphrasing and stuff can be incorporated there, but we couldn't really come up with any good ideas. So I think I do think like story generation is one of the hardest natural language generation tasks that are out there. But yeah, like at the same time, I think like long form question answering is a task where you might have a greater user base, because like people care a lot about like knowledge and information, and like that's like this is probably like a more like this is a task that yeah, it's similar to like the open domain. It's similar I think it's similar to the reason why open domain QA is so popular these days, because a lot of like a lot of industrial applications require this kind of system. So
I'll buy that story generation is not as important as open domain QA, but I think dialogue generation is more important than either of those.
Oh, definitely. Yeah, yes.
Dialogue generation problems.
Definitely, it's super important. Yeah, I completely agree with you.
Awesome. Thanks.
Do we have any other questions from the audience for Kalpesh? Oh, okay, great. I think then we can end the seminar. And again, thanks so much, Kalpesh, for joining us and for the great talk.
Do you mind if I ask a quick question?
Oh, sorry, Justin. Sure, go ahead.
Sorry, my mic wasn't working for a second. Hi, Kalpesh. Thank you so much for your talk. It was really interesting. I really like the long form open domain question answering part as well. So for the next steps in improving the evaluation for that work, do you foresee just doing something similar for the data set that you used, the way that you've improved like the data set for the unsupervised style transfer, making sure that the training set and validation set is more like separated, that they don't share like significant overlap, such that you can get better results or more clear results that show the capacity of the models that you've trained?
Yeah, I think that's one step, but I have been chatting with people, and like some people are of the opinion that like it may not be it may not be necessary. Like I think this just gets back to Jay's point that a lot of questions that people care about are already asked. So like it really depends on the end case, like how important are the tail questions or how important are the head questions. I think if you want to tackle tail questions and like really test whether models can like generalize to unseen knowledge, then I think it's really important to like hold out entire genres. So precisely you can do something like take the ELFI questions, remove all the questions which like have a history tag to it. Sorry, let's say have a biology tag to it, and keep all that as a validation set, and then just train on all the other genres. That could be a way like to fix this issue in ELI5. And I think both kinds of evaluation are important, like whether the model can like retrieve stuff from the training set and whether the model can like leverage unseen knowledge and like sort of answer the tail questions as well. I think both kinds of evaluation are important. Regarding the metrics themselves, so I think yeah, RuGel is definitely bad for long form question answering. And this is despite the fact that answers have 7 to 10 references. Like it's, yeah, you like the lower bounds are really concerning, I think. And moving from RuGel is going to be challenging because we don't have a good other alternative. Some people are saying that like the question answering eval for summarization is really maturing. At least that's the feedback I got while giving the NACL talk. And like some recent works are getting really good, and like they can be sort of trivially adapted to long form QA as long as you have gold Wikipedia articles which support the answer. And the nice thing is that people have collected like 1,500 validation pairs for ELI5 where the gold answers directly supported in a Wikipedia article. The very same corpus was used to evaluate the models in this work as well. So I think perhaps that corpus can be used with this summarization evaluation, and I think that's pretty promising. Yeah, the other kind of stuff would be like you train deep evaluator models on like stuff that you care about, maybe coherence or grammaticality or proper presentation of content. Yeah, it's sort of hard to define, but yeah,
right.
This is like broad thoughts.
Thank you so much.
Any other questions that audience may have? Okay, I hope I haven't missed anyone this time. Thanks again, Kalpesh. Really interesting talk. And with that, I think we can end the seminar and have a great rest of your day or night, everyone.
Yeah. Thank you so much. Fun to be here.
Thank you.